The first comparative graph we're going to make is a side-by-side box plot. Just as you would expect, we're going to be making two box plots using both the data sets. So I've already entered the data into my calculator and I've sorted them, so period 1's data looks like this from least to greatest. All right, so to make our box plot, we need our 5-number summary. We've got our minimum here at 60, maximum at 99. Our median this time is between 80 and 88, so that is a median of 84. I have Q1 right here at 67 and Q3 up here at 93. Before we move on, since we're making modified box plots, we want to double check for any outliers. So in this case, our IQR, which is 93 minus 67, is 26. We're looking to see whether or not we have any outliers to the left of our data, and then to the right. In order to be an outlier in this data set, our data value would have to be less than 28 or something greater than 132. As you can see in this data set, none of these data points are less than 28 or greater than 132. So let's move on to period 4's data. Same deal, I've already put it in my calculator, so I'm just going to list them least to greatest. All right, so minimum is here at 54, maximum at 95. This time our median is between 83 and 87, so that is an average of 85. Over to the left, we've got our Q1 at 76, and to the right, we've got our Q3 at 90. Again, since this is a modified box plot, we're going to make sure that we look for any outliers. So our IQR this time, 90 minus 76 is 14. So following our outlier formula, I've got Q1 minus 1.5 the IQR, and then I've got Q3 plus 1.5 the IQR. Any data point less than 55 or greater than 111 is considered an outlier. So looking at the data set, yes, we do have one outlier. 54 is an outlier. So we just want to make sure that when we make our box plots, we're going to put an asterisk right there. So next, to make our modified box plot, we need our number line. All right, and we want to make sure that we're labeling our units. Our units here are quiz scores, and these are by percentages. Yikes. All right, so smallest number in both data sets is 54. I'm going to be counting by 2. All right, sorry about the handwriting, this is pretty bad. All right, so to make our box plots, we want to make sure that we're labeling which class is which. So up here I'm going to put my period 1 data. Down here is going to be my period 4 data. Period 1, we've got a minimum at 60, Q1 at 67, median at 84, Q3 at 93, and our maximum at 99. All right, moving on to period 4, we know that there's an outlier at 54, so I'm putting an asterisk right there. Our new minimum is going to be the next smallest data point, which is 63. We saw that the Q1 was 76, median is 85, Q3 is 90, maximum is 95. and that is a side-by-side box plot. We're going to use the same data as above to create a back-to-back stem plot. So I'm not going to reorganize the data, I'm just going to use the same list that I have above. So to do a back-to-back stem plot, it's the same thing as the stem and leaf plot that we're used to, but this time we're going to have both sides filled. So in the middle of these two lines, I'm going to have my stems. So the smallest was 54, so I need a 5, and since our largest was 99, I need to make sure I'm going all the way up to 9. Above, I want to make sure I give my labels, so period 1 scores are going to be here. Period 4 scores are going to be here. So the only difference is that when we're doing period 1, we actually read it backwards. So in period 1, the smallest data point was 60, so I'm going to go to the 6, and I'm going to place a 0 here. Then we had a 65, 67, 67. Then we had 78, 9, we had 80, 88, then we had 91, 93, 93, 94, 94, 99. Same thing goes for period 4. This time we're going to read it forward like we're used to. The smallest data point was 54. There were 63, 64, 76, 77, 78, 83, 87, 88, 290s, 291s, and 95. That is a back-to-back stem plot, and you can see if you rotate it from side around, you know that you can look at the distribution like we were talking about. We can also talk more about that later. The last thing we want to make sure we include is a key. So our key for this one, I'm just going to make up some numbers. So if I have a 4 and a 2 and a 5 and a 1, this represents 42%. This represents 51%.